Okay, welcome to this lesson on balanced and unbalanced forces. So we are moving into the topic now. We've got forces, friction is friction useful, and here we are, balanced and unbalanced forces. So the last lesson really on forces, and some interesting conceptual ideas that we need to get on top of here. So in this lesson, what will we do? I can list 5 effects of forces on an object. We'll do that quite quickly at the start. I can describe how balanced or unbalanced forces would affect an object. So the first thing I'd like you to do is put this link in. I'll put it in the Firefly and the YouTube comments as well. So type in that link and go to YouTube. And what I'd like you to do, it's within the first 30 seconds, watch this video and write down what are the 5 effects that forces can have on an object, and you put them in here. 1, 2, 3, 4, 5. Once you've got those down, carry on, watch the rest of the video and make down any of your own notes. So the same video, make down any of your own notes. It's not a long video, so make down any of your own notes once you've gotten those first 5 things which come in right at the start of the video, and then make any of your own interesting little notes that you've put down for the rest of the video. Okay, go ahead and do that now, and then we'll carry on with the next part of the lesson. Okay, again, very simple. The best way to express this is some really good videos that explain this. So what I'd like you to do in this lesson, go to watch this video. Again, I'll put the link in. Again, the link in that you can see up here. I'll put that in Firefly or YouTube. And what I'd like you to do is watch the video. The arrows you want to draw in here belong to 1 minute and 13 seconds, but don't just skip to that. I want you to, what do the arrows look like which represent the forces do when the cycle is at a constant speed? Then draw in the same arrows, same forces, to show what the arrows would look like when increasing his speed. And then draw on the arrows when the cyclist is at a higher constant speed than he was in question 1. So please go ahead and do that now, and I will go through the answers in a minute with you. Okay, well, in the first one, what are we looking at? Draw the arrows when the cyclist is at a constant speed. You should have ended up with something that looked a bit like this. You should have ended up with a driving force or a push force that was behind them and a resistive force. And when you have a resistive force and a driving force, and they are balanced, can you see the forces all look pretty much the same here, but they're in the opposite direction. The arrows are the same, but they're in the opposite. Then they balance each other out, they cancel each other out, and that will give us that doesn't mean clearly that the cyclist is stationary. It means the cyclist is not changing his speed. He's not getting any faster or when he's getting any slower. So look at down in question 2, draw labels at the arrows when the cyclist is increasing his speed. Now the key point here is that if you're going to increase your speed and you're already cycling, then you're already going to have some resistive force, call it wind resistance or whatever. But clearly the force that you provide needs to match that and be bigger. So what I'm looking for here is that when you're increasing the speed, the arrow must be bigger. Either you can just draw it by length. Normally we try and represent it with length. Sometimes we put numbers on them. But clearly you can see this arrow is bigger than that one. And because he's going in this direction, then he's going to increase his speed from right to left. Okay. Final one. Well, if the cyclist is travelling at a higher speed, but he's still travelling at a constant speed than he was initially, well, clearly he's going to have more resistive force from air resistance. And if he's travelling at a constant speed, that must mean his driving force that's driving him forward, his push force that's driving him forward, must be equal. So can you see how these are different? In these two, the forces are balanced, but balanced at a higher speed. So he's got more drag, so he needs more push force driving him forward. Okay, let's jump to these now. The arrows represent the forces on the objects. All the objects are moving from left to right. Which object is getting faster? Which object is decelerating? And which object has a constant speed? Well, give yourself a bit of thinking time. Pause the video now, and then I'll go through the answers. Okay. The lorry in the first one, the answer's coming. So pause, we've even had to go answering all of these. You can see the driving force is going that way. So that's the force that fundamentally coming from the motor through the wheels and pushing the truck forward. And this must be the resistive force, which is slowing it down, probably caused by air resistance and all other things. And if you look at those arrows, you can see that they are pretty much just by sight balanced. So this will be traveling at a constant speed. And that's because the forces are balanced. Now, look at this one, in the motorboat. Can you see which force is big? It's the driving force that is bigger than this resistive force. So this would tell me that this object, if it's got a bigger force in the direction it's moving than the resistive force in the opposite direction, then this will be getting faster, accelerating. Now, this car, so I suppose in the boat, the person might have just increased the throttle and putting more gas into the propeller and the engine here, getting it go faster. Now, here's a car. Now, this car is actually, as it says in the question, all the objects are moving from left to right. So this car is actually moving from left to right. Okay, it's moving from this side of the screen to that side of the screen. But the driving force is less than the resistive force. That doesn't mean it's going backwards. It just means it's going to get slower. And this object must be decelerating, okay? Because the resistive force is less than the driving force. One more question then that we can have a little look at, and then if you want to, you can go and rewatch the videos again. Okay, here's this question, and in the question, the car is moving from left to right. So let's just put that in. This is an arrow just to show the movement of the car. When the motor was switched off, the car slowed down and then stopped. So the motor's been switched off. Let's have a go. The motor's been switched off, the car slowed down and then it stopped. Well, if the motor switched off, then in fact that would mean no forward force. And the car slowed down, that means it's going to accelerate. Why would that happen? So when there is when the motor switched off, the forward force will disappear, but the friction won't. The friction won't disappear because the car is still moving forwards, even though it might not be the friction will probably be reducing as it gets slower and slower, and eventually the car will come to a stop. So, which of these is, while the car was slowing down, which of the following was true? Friction force was 0. We know that's false. Forward force was greater than 0. That is false as well. They are both false, because if the engine's being turned off, there would be no forward force and the friction would be greater than 0. Let's skip that one. Friction was 0. Friction would not be 0 if it's moving forward, because there would be friction caused by air resistance. And the forward force was 0. Well, that is true, but if the engine is turned off, the forward force and the friction were both greater than 0. Well, the forward force has been turned off, so that would be 0, and the friction would be greater than 0. So that only leaves us this one to analyse. The forward force was 0. Well, that's true because the motor's been turned off and the friction was greater than 0. Yes, because it was still moving forward, but it would sort of be some friction, but it would be slowing down and decelerating. So that is the correct one there. So just make sure you watch those two videos. I think they're really good descriptive videos, and if you can understand the questions that we've done, then that's absolutely fine. Good progress to keep you on track for this course. Thank you very much. Bye bye.